Some recurrence relations can be then divided either as linear homogeneous or non-linear homogeneous. Before we proceed, we would like to check whether a recurrence relation is homogeneous or not. So we will discuss special types of recurrence relations, and if all the conditions satisfied for this recurrence relation, there is a systematic way to find a general solution. What are these properties? First, it should be homogeneous. Second, it should be linear. Third, it should have all its coefficients constants. We write it in a standard form as explained in the previous example, and this is the standard form of the recurrence relation. You have subscripts, you order them from largest to smallest, and make sure that you have the first subscript is n, and these are the coefficients, okay, the numbers you multiply by each an. If any term has an, then you put it in, you put that term on the left hand side of the equal sign, and any remaining term without a subscript, then you leave it on the other side. After you do this arrangement, if the function is equal to 0, then it is homogeneous. So if there is nothing on the right hand side, after you combine all ai's in one side, it's equal to 0, then it is homogeneous. Or if there is any term, this is 1, this is 2, this is a 3, if there is any term, it does not have ai, then it is not homogeneous. Now for linear, and you know in algebraic equations or polynomial, if x is raised to power 1, then we call it linear. If x is raised to power 2, we call it quadratic, x to the power 3 cubic. And if it is inside the square root, then it is power 1 over 2, which is not linear. And if it is inside sine x, so x is not linear. So when we say that x is linear in algebraic equations, if you have the variable x raised to power 1. Now consider each of these a's, an minus, and let's call it aj, or let's call it ai. If it appears by itself in a term, it's not raised to power any number, it is not multiplied by any other ai, it is not inside the square root, it is not inside sine, then we say it is linear. And you check for the coefficients C0, C1, C2. If all of them are constant, then we say constant coefficients. These three properties we have to make sure exist, and we will show you the systematic way to find the answer. Let's go for some examples. This is the first example we have. It consists of 3 terms. This recurrence relation consists of 3 terms. an minus 5 an minus 1, and we have 7. This term has an. This term has also an, which is an minus 1, but this term does not have any ai, so it is not homogeneous. Now this term has an, appears by itself, and here has an minus 1 appears by itself, so it is linear. And all the numbers in front of ai are constant, so it is with constant coefficient. For the second one, this term has an, this term has an minus 1, and this term has an minus 2, so it is homogeneous. But this term is multiplied by 1, which is constant, but this term is not multiplied by 1, it is multiplied by equation. So therefore, not all coefficients are constant. However, it is linear. Why linear? Because an appears by itself, it is not involved in any other equation. An minus 1, an minus 2, so it is linear. The third example, this term has an, this term has an, this term has an, so it is homogeneous. Coefficients 1, minus 3, minus 4, all constant coefficients. But see this term, it is a multiplication of 2 ai's, an minus 1 multiplied by an minus 2, so it is not linear. So this is why it is not linear, because of this. For example number 4, it is homogeneous because every term has ai. And also it is with constant coefficients, because 1, -4 and -5, but it is not linear. Why it is not linear? Because here we have an minus 1 square, and it should appear by itself. So it is not linear. Last one, it is homogeneous. It is not homogeneous, sorry. Why? Because this term has an, this term has an minus, but this term does not have any ai. So it is not homogeneous. It is not linear. Why? Because an minus 1 does not appear by itself. It is inside sign. So it is not linear. However, all the coefficients of the terms are constants. So here we have a constant 1, -1, and so it is with constant coefficient.